All right, so we have a cylinder inside a cone. The cone has a radius of 5 centimeters and the cone has a height of 15 centimeters. And we want to maximize the surface area of this cylinder inside the cone. Since I want to maximize the cylinder's area, the first thing I'm going to do is I'm going to write the equation of the surface area of a cylinder, which is just the top and bottom areas, which are pi r square. So that's going to be 2 pi r square. And then this side part here, which is just the circumference times the height. That's my surface area of this cylinder. I want to eventually maximize it. So I want to derive this equation, but the problem is I have two variables here. Can't derive it just yet. So I need to get rid of one of the variables, most likely the h. Need to replace it with an r somehow. So I'm going to come up with my second equation that's going to involve this diagram. I'm going to redraw this diagram in 2 dimensions to make it easier to come up with the second equation. So let's pretend this cone, if you look at it in 2D, it's going to be a triangle. And the cylinder is going to look like a rectangle. This is what it's going to look like in 2D. I know that the height of this entire thing is 15. This whole thing here is 15. And then I know that this entire radius is 5 centimeters. Height is 15 and the radius is 5. Okay, I know that this tiny little space here, this is the radius of my cylinder. So I'll label it an R for the radius of my cylinder. That's one of the things that's going to be in this equation. And I know that this over here is going to be my height of my cylinder. So now I'm just going to redraw this out a bit more neater down here so you can understand my next step. So I've just redrawn this half of the triangle over here. Remember, this whole thing is 15 centimeters. And then I'll just draw the half rectangle in here. This whole thing is 5 centimeters. This little bit is my radius, and this little bit is my height. So now I'm going to use similar triangles to solve this. I'm going to compare the big triangle here to the small triangle over here. If you look at this small triangle, this is also my h. This over here is going to be 5 minus r. Because if the whole thing is 5 and this is my radius of my cylinder, this is going to be 5 minus r. So now let me do my similar triangles equation. So 5 divided by 15. Actually, I'll do the bigger over smaller. 15 divided by 5. So this side over this side in the big triangle equals to height divided by 5 minus r. Now all I have to do is isolate the height in this equation and substitute it there. So 15 divided by 5 is just 3. I can do that first. Then I can multiply the 5 minus r on the other side. So I get 15 minus 3r equals to my height. I'm going to substitute this over here for my height. So my surface area is just 2 pi r squared plus 2 pi r 15 minus 3r. I'm going to expand this out so that'll be easier to derive. So 2 pi r squared plus 30 pi r minus 6 pi r squared. I'll combine these two like terms. So I get 30 pi r minus 4 pi r squared. I can derive it So this is just going to be 30 pi. This is going to be 8 pi r. I can set a 0 for my critical points. The other thing is this is a negative quadratic equation. So you know a negative quadratic equation, the critical point is definitely going to be a maximum, which means it's going to give us a maximum surface area. But if you want, you can always do the second derivative test or any kind of test to prove that as well. So 0 equals to 30 pi minus 8 pi r. 8 pi r equals 30 pi. R equals 30 divided by 8. Which is 3.75 centimeters. And then I can find the height by subbing it back in over here. So 15 minus 3 times 3.75 equals to my height. Do that in my calculator. I get the height to be 3.75 as well. And now I can find the surface area by subbing it into this equation, my radius and my height. So I'll just do that in my calculator. 2 pi 3.75 squared plus 2 pi 3.75 times 3.75, which is basically the same thing. That gives me a surface area of 176.71 centimeters square. So this is the maximum possible surface area of that cylinder.